Morning, dear students. Today we will discuss the numericals based on physics chapter 10. Let's start with the numericals. So here question 12 in the exercise says gravitational force on the surface of moon is only 1/6 as strong as gravitational force on the earth. What is the weight in newtons of a 10 kg object on the moon and on the earth? So here weight of an object on the moon will be 1/6 of the weight of the object on the earth. So weight is equals to mass into acceleration. Acceleration due to gravity g here is equals to 9.8 meter per second square. Therefore weight of 10 kg object on the earth is 98 Newton when you multiply 10 into 9.8. So the weight of the same object on the moon will be 1/6 of 98, that is 16.3 Newton. Let's see next question. Question number 13. A ball is thrown vertically upwards with the velocity of 49 meter per second. That means in 1 second it can cover 49 meters. Calculate the maximum height to which it rises. Number 2. The total time take to return to the surface of earth. So according to the equation of motion under gravity, v square minus u square is equals to 2gs. Here u is initial velocity of the ball, v is final velocity of the ball, s is height achieved by the ball, g is acceleration due to gravity. At maximum height, the final velocity of the ball is 0, that is v is equals to 0 meter per second, and here initial velocity u is given 49 meter per second. Now during upward motion you have to consider gravity in negative because it is going against gravity, so that is minus 9.8 meter per second square. Let h be the maximum height attained by the ball. So let's use the formula v square minus u square is equals to 2gh. So here v I'll substitute with 0, u I'll substitute with 49 square minus is equals to 2 into minus 9.8 into h. Let's make h as a subject. You will receive an answer 122.5 meter, which is approximately 123 meter height achieved by the ball. Now let t be the timing taken by the ball to reach the height of 122.5 meter. Then according to the equation v is equals to u plus gt. Here v is 0, u is 49, g is minus 9.8 and t we are looking for. So my t is equals to 49 upon 9.8. I'll get the 5 second. But time of ascent is equals to time of descent. So therefore total time taken by the ball to return is 5 plus 5, 10 seconds. Question number 14. A stone is released from the top of the tower at the height 19.6 meter. Here you have to take gravity positive because it is going towards the positivity of gravity. Calculates its final velocity v just before touching the ground. Let's start with the example using v square minus u square is equals to 2gs. U I will take 0 meter per second, v that is the final velocity of the stone, s that is the height of stone which is 19.6 meter, and g is the acceleration due to gravity which is 9.8 meter per second square. Substituting the value, I'll get value of v that is 19.6 the whole square. So v is equals to 19.6 meter per second. Hence the velocity of stone just before the touching the ground will be 19.6 meter per second. A stone is thrown vertically upward with the initial velocity of 40 meter per second, taking 10 meter per second square. Find the maximum height reached by the stone. What is the net displacement and the total distance covered by the stone? Let's start with the solution. According to the equation of motion under the gravity, v square minus u square is equals to 2gs. U is initial velocity of the stone which is 40 meter per second. V is final velocity of stone, which is 0 meter per second. S is the height of stone. G, I'll take gravity, which is minus 10 meter per second square. Let's substitute all the values in the given formula. I'll make H as the subject. I'll receive 80 meter height. Therefore, total distance covered by the stone during upward and downward journey is 80 plus 80, that is 160. Net displacement during upward and downward journey will be plus 80 minus 80 is equals to 0. Let's have a look to one more example. A stone is allowed to fall from the top of the tower, which is 100 meter in height, and at the same time another stone is projected vertically upwards from the ground with the velocity of 25 meter per second. Calculate when and where two stones will meet. Now let the two stones meet after the t time. When the stone drops from the tower, the initial velocity u is 0 meter per second. Let the displacement of stone in that time t from the top of the tower be s. So acceleration due to gravity g is equals to 9.8 meter per second square. From the equation of motion, s is equals to ut plus 1 half at square. So I'll substitute all the values. S is equals to 4.9 t square, that is my equation number 1. Now when the stone is thrown upwards, so initial velocity u is equals to 25 meter per second. Let the displacement of the stone from the ground in the time to be s. Acceleration due to gravity g is equals to minus 9.8 meter per second square. Equation of motion, s is equals to ut plus 1 half at square. Let me substitute all the values. I'll get the second value. S dash is 25t minus 4.9 t square. The combined displacement of both the stone at meeting point is equal to the height of tower 100 m. So S dash plus S is equals to 100. Let's add both equation 1 and equation 2. That cancel with minus 4.9 t square plus 4.9 t square. So let's make t as a subject. 100 upon 25, that is 4 seconds. In 4 seconds, the falling stone has covered the distance as 4.9 into 4 raised to square, that is 78.4 meter. Therefore, the stones will meet after 4 seconds at the height 100 minus 78.4. That is 20.6 meter from the ground. Let's see one more question like this. A ball is thrown vertically is vertically returned to the thrower after 6 seconds. Find the velocity which it was thrown up, the maximum height it reaches, and its position after 4 seconds. Time of ascent is equal to time of descent. The ball takes a total of 6 seconds for its upward and downward journey. Hence, it has taken 3 seconds to attain the maximum height. Final velocity of ball at the maximum height v is equals to 0 meter per second. Acceleration due to gravity is g is equals to minus 9.8 meter per second square. Using equation of motion, v is equals to u plus 80, we have got u is equals to 9.8 into 3, which is 29.4 meter per second. Hence, the ball was thrown upward with the velocity of almost 30 meter per second. Let the maximum height attained by the ball be h. Initial velocity u is equals to 29.4 meter per second. Final velocity v is equals to 0 meter per second. Acceleration, as I have to take negative, it is minus 9.8 meter per second square. Using the equation of motion, I'll substitute all the values here. So value of h is equals to 44.1 meter. Hence the maximum height is 44.1 meter. Now ball attains the maximum height after 3 seconds. After attaining this height, it will start falling downwards. In this case, initial velocity u is equals to 0 meter per second. Position of ball after 4 seconds of the throw is given by the distance travelled by it during the downwards journey, which is 4 seconds minus 3 seconds, that is 1 second. Let's substitute again all the values. I get S is equals to 0 into 1 as U is 0 plus 1 half A is 9.8 into T square, that is 1 square. So S is 4.9. So now total height is 44.1 meter as we have already got in the previous equation. This means the ball is at 44.1 minus 4.9, that is 39.2 meter above the ground after 4 seconds. So in this lesson you are supposed to do the gravitational base calculations and the numericals. I hope you have done all these examples in your notebook correctly, and please practice this such examples because they are generally asked in 2 to 3 marks. Thank you and see you with the next videos. Bye bye.